Welcome to Neuromuscular Physiology and Pain. In this lesson, we will explore how nerves activate muscles, how the body monitors movement and tension, how the autonomic nervous system changes body state, and how pain is produced and experienced. Let's begin with muscle contraction. 肌肉收缩. A skeletal muscle cannot contract by itself. It requires a signal from a motor neuron, 运动神经元. The point where a motor neuron communicates with a muscle fiber is called the neuromuscular junction, 神经肌肉接头. When a nerve impulse reaches this junction, the neuron releases a neurotransmitter called acetylcholine. Acetylcholine binds to receptors on the muscle fiber membrane and produces an electrical signal. This signal causes calcium to be released inside the muscle fiber. Calcium allows two contractile proteins, actin, 肌动蛋白, and myosin, 肌球蛋白, to interact. Myosin pulls actin toward the center of the sarcomere, shortening the muscle fiber and producing contraction. ATP supplies the energy for this process. ATP is also required for myosin to release actin, allowing the muscle to relax. Therefore, muscle relaxation is not simply the absence of energy. It is also an active physiological process that requires ATP. A motor neuron and all the muscle fibers it controls form a motor unit. 运动单位. Small motor units provide precise control, while large motor units generate greater force. The nervous system also needs information about what the muscle is doing. Two important sensory receptors provide this information, the muscle spindle and the Golgi tendon organ. The muscle spindle, G-Thor, is located within the muscle and lies parallel to the muscle fibers. It detects muscle length and the speed at which the muscle is being stretched. If a muscle is stretched too quickly, the muscle spindle activates the stretch reflex, 前张反射. The stretched muscle contracts to resist sudden lengthening and protect itself from injury. This explains why rapid or forceful stretching may cause the client to tighten rather than relax. Slow, comfortable stretching gives the nervous system more time to interpret the movement as safe. The Golgi tendon organ, 骨肌腱器官, is located near the junction between muscle and tendon. It responds primarily to muscle tension. Traditionally, the Golgi tendon organ was described as causing immediate muscle relaxation when tension became excessive. Modern physiology presents a more complex picture. Its signals contribute to the nervous system's overall regulation of force, movement, and protection. For massage therapists, the practical lesson is simple. Forceful pressure does not automatically produce greater relaxation. The client's nervous system continually evaluates whether touch and movement feel safe. Next, let's review nervous system pathways. Sensory information travels toward the central nervous system through afferent pathways, 传入通路. Motor commands travel away from the central nervous system through efferent pathways, 传出通路. Remember, afferent arrives at the central nervous system. Efferent exits from the central nervous system. The somatic nervous system, 躯体神经系统, controls skeletal muscles and carries conscious sensory information. The autonomic nervous system, 自主神经系统, regulates internal organs, glands, blood vessels, heart rate, and digestion. The sympathetic division, 交感神经, supports alertness and action. Heart rate may increase, breathing may become faster, and blood flow is redirected toward tissues needed for activity. The parasympathetic division, 副交感神经, supports rest, digestion, recovery, and energy conservation. Massage is often associated with relaxation and increased parasympathetic activity. However, we should not guarantee that every massage will create the same autonomic response. Pressure, temperature, environment, previous experience, anxiety, pain, communication, and trust can all influence how the nervous system responds. Finally, let's discuss pain. 疼痛. Pain and tissue damage are related, but they are not identical. Nociception, 伤害感受, is the nervous system's process of detecting signals that may represent actual or potential tissue threat. Pain is the conscious experience produced when the brain interprets the available information as threatening. That interpretation is influenced by tissue signals, emotions, attention, memory, expectations, sleep, stress, and the surrounding environment. This helps explain why a person may experience severe pain with limited tissue damage, or significant tissue damage with surprisingly little pain. Pain may also be referred, 牵涉痛, meaning that it is felt in an area different from its actual source. For massage therapists, Pain should never be treated as proof that the technique is working. If pressure causes sharp pain, burning, tingling, numbness, electrical sensations, or increasing weakness, reduce the pressure or stop the technique. New neurological symptoms, unexplained severe pain, or progressive weakness require appropriate medical referral. To summarize, motor neurons initiate muscle contraction. Calcium and ATP make contraction and relaxation possible. Muscle spindles monitor length and speed of stretch. Golgi tendon organs contribute information about tension. The autonomic nervous system regulates the client's overall body state. Pain is a protective experience shaped by both body signals and context. Before moving to the next lesson, consider this question. Why might slow, comfortable touch reduce guarding more effectively than forceful pressure, even when both techniques contact the same muscle?